All right. So my name's Ryan Feigenbaum. I am the senior developer advocate here at GrowthBook, and I'll be kind of emceeing things today. And like I said, we're going to be talking about our 4.3 release, which we have this subheading here: faster experiments and deeper insights. You can see some of the things we're going to talk about. I am super excited though to be joined by Luke and Adriel, and I'll let them give a quick introduction to themselves.
Hey everybody, my name's Luke. I am a data scientist here at GrowthBook.
And hey all, I'm Adriel. I'm a software engineer here at GrowthBook, and I'll be talking about features that actually I didn't work on. So credit to where it's due for Michael Simper and Bryce. But this will be exciting.
But it is it's very exciting because they did work on many of these features, even if they're not presenting on the exact ones they did, but they know GrowthBook in and out. So very excited to have them here, and I'm very excited about this release. Kind of going back through it as we've been rehearsing for this webinar, I feel like there's a lot of like little things that really add up to more than the sum of the sum of their parts, and it's just this really kind of crisp experimentation experience that has come together, and that's only going to improve. But let's kind of give you a preview of everything we're going to talk about today. So we have three parts to this, and like I said, it's going to be some slides to kind of give you an idea of what the concept is, but then we're also going to jump into live demos in GrowthBook. The first part is going to be metric upgrades, and this is just going to be some of the upgrades we made to doing metrics in GrowthBook. And then two, it's going to be some of the improvements we made to experiment analysis. And the star of the show there is really going to be post-stratification. We're going to talk about that. Very excited. And then the third part, we're going to talk about how we've improved the feature flagging aspect of GrowthBook along with targeting. And like I said, you can see this bright yellow box here pointing at the slido.com URL with the login code. And that will be on these slides throughout. So you can use that to ask questions at any time. Because once we finish with the demo, we'll jump into question and answer. And I'm very lucky here to have Adriel and Luke here. So experts on the product. So let's get right into metric upgrades. And the way that I'm going to do this is Luke and I are going to talk about this on the slides for the metric upgrades and the experiment analysis, and then we'll go into a live demo. So this first thing that we're going to talk about is daily participation metric. This is a brand new metric we introduced in 4.3. And you can see here that what it is, it's active days divided by days exposed, which is average across users in each variation. But I'll let Luke kind of give a little bit of what the problem it is that it solves, and then what kind of use case you would maybe reach for this metric.
Hey, awesome. Thanks, Ryan. Yeah. So GrowthBook now permits you to easily track how often users are engaging with your platform or specific aspects of your platform. So what our daily participation metric does is it measures engagement at the user level. And so it measures each user's specific engagement, and then it averages across users to estimate their overall engagement. So as an example, say that you have an online learning platform and you want to know how often users are engaging at least daily with your platform. Now we can track easily this data at the user level, and then create a metric from it, and then it can give you this average participation.
Very cool. Just makes things much easier when you're setting this up. We will look at it a little more in the app, but again, if you have questions about this, feel free to add them. I'm going to move to our next one here, and this is metric slices. And metric slices, the more I use them, the cooler they are. I love it. Note that this is an enterprise feature, but we released this in 4.2, but in 4.3, we've gotten just like a huge upgrade to this. And what slices are is basically lets you break down your metric into different categories. And the real kind of benefit here is that you can set this up once and then just have it populated for all of your experiment results without having to do anything extra. And you can see here the way that it's broken down in this experiment result screenshot, where we have a feature adoption rate metric but it's broken out into the different plans. And so you can see the lift compared or relative to the other plans. And again, I'll let Luke kind of give you some more information on this.
Awesome. Thanks, Ryan. Yeah. So, just like Ryan said, the big change here is really ease of usage. So, suppose that you have this feature adoption rate, and then you have it also measured by all of these different subplans, rather than having to create and maintain a bunch of related metrics. Now we make it really easy to just create them once, using a dimension column, and then they're automatically maintained. So really your bookkeeping should be a lot easier. But as you can see in this example here, let's say that it is of interest to know what your feature adoption rate is by plan. So what you can do is you can essentially slice this feature adoption rate, and you're just splitting it by plan type. And you can see also that it is really kind of like slices of a cake almost. And that, these percentages here, if you look in the control column and if you look in the treatment column, they actually do sum up to the total feature adoption rate. So it really is just kind of like you're dividing your metric into different components. And then another thing to notice is that the user count is staying the same across all of these different components. So again, it really is just kind of like chopping or slicing this metric a bit, and then allowing you to gain deeper insights into your data.
Awesome. Thank you, Luke. Again, this is a very powerful feature, and there's a lot of kind of ways, like Luke said, we've made this a lot easier to use. So if you have questions about this, again, use that Slido link and let us know. Let's move on to now the second part now, experiment analysis. And this is where we kind of really get a brand new feature in GrowthBook that's very cool. And this is post-stratification. And this is, again, an enterprise feature. And this is just, I'll give the basic kind of definition that it's a variance reduction technique that helps you to get tighter confidence intervals and get to results faster. Um, I'm going to let, though, Luke kind of really give you a good explanation here, because he is the one that worked on this and really made it what it is in GrowthBook, which the nice thing is that you don't need to know every single kind of thing of how this is working, because it's very easy just to enable for your experiments. But I'm going to kick it over to him and let him give a little bit more explanation of what post-stratification is.
Awesome. Thanks, Ryan. Okay. So yeah, with post stratification, basically what you're doing is you're just using the information better that are in your data. So historically in GrowthBook, if you knew that there were differences in some of your user subgroups, we weren't able to kind of exploit those differences to give you narrower confidence intervals or give you faster results. And now we're able to better do that. So as an example, suppose that you know that Chrome spenders are, or I'm sorry, Chrome users spend more money on your platform than Edge users do. Then now we're able to leverage that information and again, kind of give you more information faster. And we're doing this through post stratification. And if you have any kind of like statistics or experimental design or data science background, then big picture, what you're doing is, ideally what we would do is we would run a blocked experiment. And instead we're basically saying, well, we can't run a blocked experiment in GrowthBook. But what we're going to do is we're going to like analyze our results and see what our results would have looked like if we had run a blocked experiment instead. And so blocking is a technique that you use to create apples to apples comparisons. And that's essentially what we're doing here.
Awesome. Thank you, Luke. And so I'm not a data science, data scientist. And so I've been talking to Luke about, trying to really understand like how this is working. And so he shared this analogy with me, which is really fun, but he also did a really good job of crystallizing kind of how post strat works. And so I'll let him take it away here. But this kind of really brought it home for me.
Great. Thanks, Ryan. Yeah. So suppose that you invented a pill and you think this pill can actually help people jump higher. And, you being a very rigorous scientist, you're going to run a randomized controlled trial. And sadly, though, you are limited by the fact that the only people who sign up for your clinical trial are the 12 Cleveland Cavaliers, who are basketball players and are already great at jumping, and then 12 growth bookers who can barely jump over a piece of paper. Um, and so you have these two very distinct subgroups. And so if you were to run a simple randomization where you just take all these 24 people and you randomly assign them into two equal groups of 12, then in many of those randomizations, 7 of the Cavaliers would end up in treatment by chance, which would make your treatment group look good just because the Cavaliers are going to be able to jump much higher than the growth bookers. And then similarly, if by chance, there were 7 or 8 or 9 growth bookers in treatment, then, your clinical trial is going to look like a massive failure. So basically what Post-Strat does is it enables comparisons within these groups. So it says, okay, we are, for the Cavaliers who were randomized into treatment, we're going to compare their jumping ability to the Cavaliers who were randomized into control. And then we're going to do the same thing for growth bookers. And so now you have these two estimates of the lift across these two different groups. And big picture, all Post-Strat does is it weights these two estimates to combine them together to give you your final lift estimate. So even if you do have this chance imbalance where there are 7 Cavaliers in treatment, now this is not such a big deal because you're just using this apples to apples comparison to begin with. So, again, big picture, all you're doing is just leveraging the information in your data better. And this is going to, number one, this information is going to result in tighter confidence intervals. And number two, it's going to just help you experiment faster.
Cool. Thank you, Luke. Again, quick slide here just about how you can enable this in GrowthBook. Pretty simple. You can go to settings, general experiment settings, and there's this toggle to set on post-stratification by default. You can see there's a note here about having pre-computed dimensions, but it's very simple to set up, and we have good docs on this if you need to. Before we get to this advanced features, I'm going to let Luke now actually show us everything we just talked about in the app. And again, have your Slido questions. If you want to put them in, go ahead and put them in. But Luke, yeah, I'll turn it over to you.
Okay, great. Let me just share my screen here. Just a moment, please. I just sent a request to share.
Should be good.
Okay, thank you. Okay. Okay. Are you able to see my screen?
Yeah.
Okay, great. Thank you. All right. So the first thing I want to do is just show how to create the daily participation metric. And this is super easy. So all you want to do, you can see that in the app, I'm located at my fact table. So this fact table is called covariant imbalance orders. And then like you would for any fact metric, you're just going to go to add metric. And so perhaps you want to call this metric daily participation. And then for your type of metric, we have this new metric type here that you can select called daily participation. And this is super simple to create. So all you want to do is just select that metric type. And then if you want, you can add row filters. So if you want to add some type of event name, so you're again saying, hey, how often did somebody come to the platform? If that's registering an event in your fact table, then you can just use that every time that row comes through for that user. If you want to do something like, hey, I want to know how often a user is spending any kind of money on my platform, then you can do something like, hey, I want to know how often we have an event where the revenue is bigger than 0 for this user. And then we're just going to track this at the daily level, and then we're going to average this across days for that user. And then finally, the total metric is going to be that daily average averaged over users. So this creating this metric is super simple and also I think like really useful.
Awesome.
So that is how you create a daily participation metric. Now I'm going to talk about how to enable metric slices. And again, you're going to start at your fact table. And in the SQL for your fact table, you need to have that dimension column already set up. So, you can see here's my SQL snippet. And then I have my column set up here. So what I want to do is I want to have revenue broken down by product family. And so, the way that I would have to do this in GrowthBook in the past is for each different product family type, I would have to create a different metric for revenue. Now I'm just going to be able to create a bunch of metrics quickly. So what I'm going to do is I'm going to edit this. And then I just want to say, hey, for this fact table, I want to create auto slices. And so this is going to enable for all of the metrics in this fact table, you to create metric slices if you want. And so when I click on these enable auto slices, this comes up. I had a recent run where we queried the fact table to get some of the most common values for product family. So in the product family here, you can see that in this fact table, you often have whether your apparel type is sustainable or denim or loungewear, etc. So this is going to enable you to get revenue slices or get revenue estimates by each of these different slices. So if you need to, you can use this. You can populate these, but these are already pre-populated. And then I'm just going to click save. And so now this little icon here is going to indicate that auto slices are enabled. So now the auto slices are enabled for this fact table, then I just need to add that to the component metrics. And so I'm going to go to auto slices here on the metric page, and I'm just going to click product family ID, and I'll click save. And so there were 10 different slices. There were 10 different apparel types in the product family ID. And so by doing that, I've now created and can easily maintain 10 different metrics. So this is much easier and faster. And so,
Cool. I love it. I love it.
yeah, thanks, Ryan. I think, and Audriel, I definitely need to give him a lot of credit here. He put a ton of work into this, and I don't know, maybe he should have presented it. I feel like I don't necessarily deserve this, but that's okay. I guess I'll take it for now. So, another thing that Audriel put a ton of work into is also just redesigning our results page, which I'm super excited about. So, what I want to do is talk about that for just a minute. There we go. Okay. So I'm going to get to the filters and the metric slices in just a minute, but I do want to just talk for a minute or two about some of the changes on our metric results page. And so you can see that it's just cleaner and crisper. We used to have icons down here, like for being able to look at like kind of little small time series graphs. And now those are gone. And we've now just made more room for the actual results and made it easier for you to focus on kind of your key results. And then we've also added this really cool feature called metric drill downs. And I'm going to show you just one or two aspects of metric drill downs here, and then I'm going to come back to it in a minute. But at a high level, if you now want to see like a bigger, more comprehensive picture of your time series graph, then all you have to do is just click in the metric row, and this is what's going to appear. And so this it's showing that same main result, so you can kind of drill down and look into that main result, and then you're also getting a big, like easy to see picture of your time series graph. So it's much more visible. And then for customers who aren't quite as familiar with GrowthBook, all this time series graph is this confidence interval band right here. is that rotated 90 degrees and then plotted over time. So you can see that we have two different variations here. And so there are two different confidence intervals. And so again, if you were to flip those and then create snapshots, historical snapshots over time, that's what you're seeing here. So just at a high level, I feel like this looks much better. And you're able to get other data that we're going to talk about in just a minute on some of these other tabs. But anyway, I feel like this looks great. So
Yeah.
um,
Second that.
and part of the motivation for needing to move some of this stuff into the drill downs tab, which again is super easy to do, is we have additional functionality now. And a big part of that is additional functionality is the filters. So on the one hand, and I actually need to update these results here. It's very empowering now that we have metric slices, and it's very easy to add all of these different components, add a lot of metrics to an experiment. But, you can see that now that I've easily added all of these, this is a ton of information to look at. So, and it's a lot of scrolling. So again, it's very empowering. It's great, but it's also a lot for the UI. And so one of the big new functionalities is filters, and these are super cool. So for example, if you wanted to see your revenue breakdown and you just wanted to see it for sustainable, let's say, then you can just click on that and the UI updates immediately. If instead you wanted to see something like just by all product family, then you can see that here, and you can see that before there were some region slices shown, and all of those are hidden. Instead, if you wanted to see just region instead of product family, then that's showing up here. But really, the filters make it super fast and easy to be able to compare results across different metric slices, and or to see just a few different metric slices if you want. So it's giving you the ability to just focus on exactly what you want to look at.
Yeah, so nice. So nice.
Another functionality that I want to demonstrate, though, just quickly, is if you want to, after you are taking different looks at your data and you want to add those to an experiment dashboard, then you can just go to these three dots right here and click on Add to Dashboard. And you can create a new dashboard if you want. Just go to Save and Continue. And then those are going to appear right here after it loads. And so these will be saved for posterity. So that way, if you want to show the results to somebody else, or if you want to kind of keep deep diving later, then those results are available. So, okay. So I've showed filters, and I have showed metric slices. I think the last couple of components that I wanted to show, one was just on I wanted to keep showing some of the drill down information. So we showed this overview tab before, where you have the main result and you have the time series graph, and then you have some of those metadata about the metric. If, for example, actually, I don't want to use this metric. Apologies. Let me just clear that filter. So I want to do it for this one. If you want to, for this primary metric, to see the slices for that metric, then that is going to be on this slices tab in the drill down. And this is going to help you see the time series graph for individual metric slices, which is also super helpful. So if you wanted to know, hey, how has revenue changed over time for the sustainable product family, then that's going to be here. So that functionality is really great. Oops. And then another functionality that Adriel enabled that I think is super cool is this debug tab. So I didn't actually get into it too much before, but this revenue metric is actually kind of a complicated metric. It's complicated in that we have pre-experimental data for it. So Cupid is on. We're leveraging post-stratification. And so, that adds a bit of complication to the analysis. Just for purposes of this example, this analysis is in a Bayesian setting, and I used an informative prior, and so that affects the results. And then finally, this metric is also capped. I think it's something like P90. And just as a reminder, if you don't know what capping is, then it takes the largest values of your metric and it replaces them with still large but less large values. So if you cap at P90, then what that means is it's going to find the 90th percentile value for the metric, and every user outcome that is above that, it's going to replace it with that P90 value. So I know all of this is a ton of information, but all of this is to say that you can have this complicated metric and you can have this complicated analysis, and we're going to enable you to easily see how all of these choices are affecting your final results. So as an example, you can see that, so this is the primary result that was shown on the main page. And it's normal to ask the question, hey, what if we kept post-stratification on, but we turn Cupid off? Like, how big of a difference is Cupid actually making in these results? And Audriel's work here is facilitating this side-by-side comparison. So rather than having to create another metric where you duplicate revenue, but Cupid is turned off for it, and then you rerun the analysis and you add it and you have to compare these two. Now you can see your violin plots side by side, and you get this for free essentially on your SQL costs too. And so it's easy to see that if Cupid is turned on or off, that's actually not making much of an impact on your results in this specific analysis. And I should just say that all of these data are not actual user data, so I don't want you to feel like Cupid isn't going to make a difference or that post-strat is necessarily going to make a huge difference. These are just for illustrative purposes. But similarly, you can compare, hey, what if we kept Cupid on and turned post-strat off, or we turned off both Cupid and post-strat. And so you get all of these comparisons here, and you can see that big picture, post-strat is making a big difference, because you can see when post-strat's off, there's a big difference in the results versus when it's on, and that Cupid in this specific analysis is not making much of a difference.
That's really, yeah. This page is it's amazing. Like, it gives you so much ability to see into how these variance techniques, reduction techniques are actually working. Yeah, really very cool.
Yeah, thank you. I totally agree. And then similarly, if you're like, hey, what if I used some external prior information when I in this experiment for my results, what would happen if I hadn't leveraged that information? You can see that for this particular analysis, it didn't really make a difference in the results. And then finally, it's also interesting to know, hey, like, I capped this metric. I took some of the biggest values and I made them a little bit smaller. What if I hadn't done that with those values? What if instead I just left them alone? Um, what would my results look like? Again, you get this nice, easy side-by-side comparison showing the cap versus uncapped results. So, and it doesn't make much of a difference here. So this is metric drill downs. Again, I think this tool is super cool. Yeah, and I think that's all I've got for my side of the demo right now.
Awesome. So thank you very much, Luke. That was really helpful walkthrough. I think the big takeaway for me from seeing all this again is that these features, so we've given you a lot more kind of insight into your metrics, into your experiment results, but also at the same time reduced a lot of the complexity of looking at that data. So it's like really a win-win. Again, if you have questions, please use the Slido link, and we'll get into that. But we have one last section here to go through to talk about some of the improvements and changes we made to feature flags and to targeting. So let's get right into that. So let me come over to my slideshow here. And one of the new things that we introduced, which is pretty cool, is nested saved groups. So if you're not familiar, we have this concept of saved groups, which allows you to either make dynamic or static targeting rules. Basically, like the example here, you could define a saved group that is beta users, and you can kind of define that and then use it in any kind of a feature flag targeting or experiment targeting. And what we did is built on that to make it now composable. So you can build more complex logic here. So in this example, we have beta users, we have internal users, and then we have this nested save group that combines them into internal beta users. Adriel, anything on that I should add or say?
No, all good. We'll get more into it during the demo.
Yes. All right. I'm gonna go then to our next one, and this is something that's I'm also very excited about. Very cool. So this is feature evaluation diagnostics, and so the goal here is really to give you more insight into what your feature flags are actually doing in production. We know that this can always be a difficult kind of thing. Like my targeting seems right, things seem to be set up properly, but I'm not getting the results that I want. We now allow you to directly query the feature flag evaluations from your data warehouse to see what's going on with them, and this happens right on your on that feature flag. So this is a very cool thing that you can now do, and I'll give a quick kind of rundown of how it works, but then Adriel is going to show it in action. But basically, you set up in the SDK a on feature usage callback. So if you're familiar with the tracking callback, it's like that, but it's specifically for whenever a feature flag evaluates. And when that fires, then it sends off the evaluation data to your data warehouse. And then on the feature flag, that data is queried and shown. And so then you can see exactly what is being evaluated or not being evaluated on that flag, not just kind of what the rules say should happen. And then this allows you, of course, to debug with real data. So this is, I think, going to help a lot when you have some of these tricky debugging issues, or just to kind of have some confidence in knowing that, okay, this thing is firing, seems to be working, everything looks good there. So that's, I think, pretty exciting. And before we get to that last one, I'll actually turn it over to Adriel so you can show some of this in action.
Cool. Let's do this. Here, let me share my screen. Can you see my screen, Ryan?
Yes.
All
Yes.
right. So let me start by demoing and talking about saved groups. So as Ryan said, we have this concept of saved groups. There's two ideas of saved groups on our side. ID lists, which is, as the name describes, is a fixed list of IDs that you can manage. On this case, we have a list of users that opted in to be on the beta group. And we also have a saved group for internal users, this one is dynamic. And we're saying that if a user's email, this is the attribute that we pass when we're evaluating the rule, matches the pattern of growthbook.io, we are treating them as an internal user. So what we can do right now is for ease of use and also ease of maintaining, so we can have single source of truth, is create a beta internal user. We'll target by, on the top, you will see a list of all the attributes, but if you scroll down, we have this option regarding other saved groups, referencing other saved groups. So I'll say in this case, a user needs to be in both the beta and internal users to be considered a part of this group. Additionally, we now have ORs in all of our targeting, that I could say if a user is in either of those groups by configuring it like this. So if the user is either on beta or if they are in internal, we would consider them to be part of this group. On my case, we'll keep this scenario. So we have a beta internal users, which would be both of them. So this is also dynamic. So if we update internal users targeting, or if we update the beta users, the beta internal user group will automatically be updated. So we don't need to duplicate this logic in many different places. To give an example, here I have just a demo feature flag that is currently being evaluated to off. If I create a new rule on my dev environment to force this to be true for if a user is in any group, on this case, I have the beta internal user. This is a nicer way than saying like selecting both groups, because as you get more complex logics and as you keep evolving and making more sophisticated conditions, it gets very hard to maintain. So if a user is in this group, we'll force it to be true. So force for internal demo. If I save this and publish my rule, you'll see that the flag is now on because I am included on both of those lists. If I come here and if I just remove all of the users and I come back, you will see that the flag is now off because I'm not, but I'm still part of the internal users given my email. So that's nested saved groups. For the feature evaluation diagnostics, as Ryan said, the main thing that you need to set up is this on feature usage callback. So this callback is called when a feature is evaluated. We have the tracking callback, which is called when an experiment is being evaluated, when the user is enrolled in an experiment, I must say. Here we are providing some of the information from our side, but you can add any other information that you consider important for this. And maybe you have a concept of organization. Maybe you have a concept of other things that should be surfaced at a high level, so you can manage that there. In this case, analytics.track would send all this data to my data warehouse. And then I would come here into my data sources. And at the bottom of the data source page, we have this feature usage query. On my case, you can see that I have a simple query that is selecting timestamp and feature key. Those are the only two required fields from this query, but also returning the value that is being forced. What is the source? Why is that? If a rule is matching, and what are the full list of attributes for this user? I could easily extract the attributes and have a user ID as a top level key here as well, if that is useful for my case. And we're getting this from this table. After you do the setup of the SDK and the data source here, this will work for all features that all of them should be logged to the same data source. So we can see here, if we go back to that same feature that I was showing you before, the one on the home page, and we go to the diagnostics tab, here's my data source as we were talking about. I can click view recent feature evaluations and we'll see what happened. So earlier I was testing and it evaluated to false because that's the default value. I loaded the page also false. That's the default value. Eventually I got true because it was forced because of this rule that is telling the condition of the IDs of the saved groups and the regex of the email. So this is the evaluated what is generated in the SDK. And you also can see here that I have my attributes. Right now, I'm just dumping the whole JSON here because I would rather have more information than less. But you can create new columns, and the columns will match the columns from your SQL query. And you can also search for things here. So this allows you to see, after you turn a feature on, if it is working. Like if you turn it on and it was like, oh, are users really being evaluated and conditioned properly based on the values from production and how that is happening. Another example here I can give is like if I force the value to be true and we'll target, let's say, username, and we'll use regex so I can show a thing. Let's say username must match Adriel, and I'll delete this rule. So if I publish, we have a single rule if username matches the pattern Adriel on our case. If I publish this and I come to home, you'll see that the flag is off, which is unexpected, given that my name is Adriel here. If I go back to the feature diagnostics tab, I rerun this query, you'll see that I'm getting false because that's the default value, so it didn't match any rules. I can check what the attributes are. And in this case, I can see, because we only have a single rule, I'm looking for the username, and you can see that the username here is actually lowercase, while here it is uppercase. I can either talk to the engineers, or on this case, what I'm going to do is just edit this to make it be case insensitive, which is a new feature we also have in many of our SDKs. I think Python, JavaScript, Rust are already up to date, and we'll have more to come. So I'll just say, now this should be case insensitive. So if I publish this and go back to the homepage, now the feature flag is on. And just to complete, if I go here and see the recent evaluations, it is on because it matched this rule of this regex. Yeah, so that's feature evaluation diagnostics. This is something that we are interested in expanding as well to make this even easier to use and more powerful. But right now, it already provides a lot of flexibility and allows you to bring as a column whatever is important for your use case. Maybe it's a user ID, maybe it is an organization ID. So you can have that set up once and it will work for all your features.
Very cool. Thank you so much, Adriel. That was really sick demo. I loved how meta it was, that you had the feature flag inside of GrowthBook. And you also gave some bonus kind of things that we released with the OR targeting and case insensitive regex. So we have here on the slide right now just some of the recap of all the things that we talked about. And then some of the other things we didn't talk about, but that which were released. We have 2 new SDKs, Rust and Roku, which is very exciting. We were always improving the query performance. We have a new API endpoints to manage experiment dashboards and custom fields, new project admin role, new custom hook option to validate incremental changes, Kerberos auth support for Trino and Presto, and then within GrowthBook, support for more AI models from other providers. So lots of different stuff. We have a blog post on all about everything here, and you can find out more about it. We also will be recording this, so if you want to share this with your team, it will be available on our YouTube page. So let's then, with all that kind of done, let's jump into some question and answer. And we already do have some here. And let me pull it up on my side so I can highlight and stuff. Remember that you can use that QR code or the Slido link to jump in and ask a question. Let's start with this one at the bottom here. Sorry, I'm just getting myself situated. I'll highlight this this recent one that was asked, which I think is a good question. So I like the Bayesian analysis. My colleagues prefer frequentist. Classic. In the GrowthBook implementation, are there differences in results between the two? I don't know if you want to take this, Luke.
Yeah. So the short answer is yes, there are going to be substantial differences most of the time if you have an informative prior. And so this isn't the GrowthBook implementation. This is just the difference between the two, the way the two frameworks work. So, but essentially, in that debug tab, you're now getting that frequentist result. So, because the frequentist confidence interval is going to be equivalent to the Bayesian credible interval under the flat prior. So on the debug tab, when I showed you, hey, here's the result with the informative prior, and then here's the result with the flat prior, it is enabling that Bayesian versus frequentist comparison. That's a good question.
And it's possible too, right? So if you made an experiment dashboard, could you have a like so the primary analysis is in one statistics engine or one method, and then you could have also it in another.
That's right, Ryan. And that is what you would have had to do before to answer this question, to say, hey, I used an informative prior, or with my Bayesian analysis, how much of a difference did that make? It would need to trigger a new results run to the stats engine. But now all of this is at your fingertips with one run.
Very cool. Um, All right. So this is another interesting, good question. Again, for you, Luke, should we use both Cupid and post-stratification together? Is there any downside?
Uh, the answers are yes, you should use them both together, and no, there's not a downside. So Cupid and post-stratification are both variance reduction techniques, but they are reducing the variance in two different ways. So Cupid is if there is some kind of imbalance in your pre-exposure or pre-randomization metric, then Cupid's going to adjust for that. So going back to the jumping example, if your 24 participants, if it turned out that the treatment group, before they took the pill, they could jump a little bit higher than the control group, and you measured this, then Cupid is going to adjust for that. Post-stratification is going to adjust for differences between, basically collection, like, groups in your data. So, again, post-stratification is going to say, hey, the growth bookers are terrible at jumping. The Cleveland Cavaliers are great at jumping. We're going to leverage this information to do this apples to apples comparison and then combine it together. And then Cupid plus post-strat should definitely be used together, because that's and we use that in our analysis when you enable it. Because what that does is it says, hey, maybe the pill helps the Cleveland Cavaliers jump a little bit higher. And maybe the pill helps the growth bookers jump way higher because we don't have any training to begin with. And so the differences between pre and post, this can differ across groups. And so if you use Cupid and post-strat together, then it can exploit those differences.
All right. Thank you for that, Luke. Uh, Mark that. So we have two questions that are kind of together with slices. So a little bit more on how they differ from 4.2 to 4.3. And then I'll kind of lump that together with this question about how they update. Um, I don't know, Adriel, if you have a good sense, or you could if you want to talk about that a little bit.
Yeah, I think I can talk to it. So the difference between 4.2 and 4.3 is about slices. I believe they are more focused around ease of use, and that touches also the part of the how do slices update. So as Luke showed, we have that use top values, for example, that will query, I think it is a 14-day look back window to define what are the top values that is worth splitting that dimension by, or slicing that dimension by. Before on 4.2, that was fixed. So if you needed to make an update to that, you would need to manually go there and do that. And nowadays, they do update automatically if you configure so. So this is a configuration on the fact table level that you can enable or disable automatic updates depending on your, uh, your desire. But they are going to be updated automatically and keep this top values according to how your traffic patterns evolve and how the data comes in. Uh, I Yes, and then I think for 4.3 as well, we made changes in the UI and potentially on how we calculate some to just make it easier to configure, easier to use, and uh, faster under the hood as well. So we require less data. Uh, yep.
Cool. That's a great answer. The self-updating or auto-updating is definitely a big improvement, and it has a lot of kind of configuration options there about, when you want to do it, if you want to lock things. So that is a very good shout out from Adriel about that. So thank you for that answer. Um, come to this question, which is, I think it's a good request. And so this will be something for Luke and I to talk about, but to add to our docs an explanation of how to interpret the info in the debug view of metrics. So, showing it with Post-Strat on and Cupid on and off and the differences it's making. Luke, does that sound like we could add something to the docs, maybe showing some examples of this?
Yeah, yes. Currently in our docs, you can, on the debug tab, we show differences in capping and Cupid. So it's just kind of a simplified version of what I showed here today. But if, for example, like adding the Bayesian comparison or adding post-strat or something, if that's also of interest, then that's something we can add.
Yeah, awesome. And then I'll also give you this Post-Strat one here.
Mhm. Yeah.
Does Post-Strat results adjust for multiple testing in the frequentist approach?
Yeah, this is a great question. And the answer is no. So, and the reason why is because post-strat, we are coming up with different treatment effect estimates by group, and then we combine all those estimates together to produce just the overall lift estimate. So it is just still one number that we are standing behind. Post-strat is connected to heterogeneous treatment effects. So maybe as a deep dive, you could say, hey, I want to know how did the pill actually do better for growth bookers than it did for the Cleveland Cavaliers? And you're doing some kind of comparison across groups. In that case, you would want to adjust for multiple testing. Um, but again, post-strat is just instead uh, coming up with a different way to have just that overall lift estimate. So it's just one number.
Thank you for that. All right, the last oh, we got another one here. I can take this. So, yeah. So one of the things we updated was support for our AI model. And then what this really does is it powers some of the AI features in the app. And so uh, there's different things like hypothesis generation, where you can help get a hypothesis generated for an experiment that aligns with your organization's kind of rules and best practices. We also have other features that allow for like duplicate experiment searches or detection. So if you're creating a new experiment, it'll check your previous experiments to see if something like that has already been created. And we use AI to do that kind of searching. And then there's other parts of the app where kind of just this sort of things that would maybe be somewhat burdensome to create, like maybe, a metric definition or kind of a results summary, that sort of stuff. You can use AI to help you write that. And what we did with the new update is have support now for lots of different models, if there's different models that you prefer. And one of the really great things that I'll shout out is, which I don't see as common in other apps, but we allow you to tweak the prompts however you want. So if there's things you want to emphasize or change, that you have full control over that. Graham and I have a video on our YouTube page where we go through many of these features, so you can check that out to learn more about it. But good question. And yeah, I think we have time for this. Well, maybe two, but we'll see. So first, let's do this one. Can you decide to apply slices to numerator and denominator, or apply it only on numerator for ratio metrics?
Do you want me to take this one, Ryan?
Yeah, if you want to take that one.
Yeah, sure. So right now, we actually apply it to the numerator and the denominator. So for a ratio metric. So if your metric is, revenue per order, let's say. So what we're going to do is we're going to slice the revenue, specific to your product family, and we're going to slice the orders specific to that product family. And then we're going to take that ratio. We've had a feature request recently where we apply the slice only to the numerator. And so we're looking at, prioritizing that. But for now, we slice both the numerator and the denominator for a ratio metric.
All right, thanks. All right, so let's see. We have like very quickly, either of you, can we apply filters to slices before it used to be an extra roll?
Yes.
Adrian or yes.
Oh, sorry.
Okay, awesome. All right. So before we're done here, thank you everyone for joining us. This will be recorded and available if you want to go back and rewatch anything. Thank you so much to Luke and Adriel for joining and showing firsthand these features that they've helped build. It's really cool to have them here, and I'm very appreciative. But be on the lookout for our we have a great webinar coming up with Luke Sonnet, our another data scientist at GrowthBook, and Ronnie Kohabi. That will be coming up soon, so make sure you register for that. Thank you, everyone. Have a good rest of your day.
Thanks, Ryan.
So, thanks, Ryan.